presentation. I thought I'd go back and look at and show you how I do this systematic sensitivity. I originally was thinking I'd do this in some sort of manual fashion, but it turns out to be, I think the way I do it is I normally do it, it's about as good as it gets. But it's a little bit cryptic, and probably you have some other way of doing it. But the basic idea, challenge you have here is you want to get a bunch of results labeled. Let me show you where we're going to go, where I want to go with this thing. And so I'm looking at results here. Okay. So you look at results here that show, this is results by, so if I go, I'll show you some tricks here. So this guy I'll go to this sheet, change this to, rename this to be pivot table. This is for the one I was doing, this is for the oil sanctions model. So this is going to be, here I'm just going to go in here and say equal to y, and it's going to be of eta equals to 0.5. So that gives me, I just made a cell using, I don't know exactly how did I end up with options, formulas, turn off R1, C1. So now, why is that not? Anyway, I don't know what, there's things happen. I don't know why it's gotten into R1, C1 notation. How do I change this? It's like R1, C1, more options, formulas, R1, C1, and I have to say accept all these Zoom things get in the way. I don't know. Say okay. So now if I go here, then okay, so what I've done is I put in a little thing in E1, I put in a thing that points to what the item is. And then I also included what eta is. So now if I go to my pivot chart, and I can go in here and say design, add an element, chart title above chart, and then I can say equal to pivot table bang E1. And then that gives me this guy, and then I can make that be higher. Right, so this gives me what this stuff is. And so that shows, and so here I've got the value down here is epsilon. So this is the elasticity of demand. So if the elasticity of demand is 0.1, 0.25, or 0.5, this is sigma, the elasticity of substitution across, this is the elasticity of substitution in trade. So that's the Armington elasticity. And so you can see there's big differences there between the Armington elasticity, somewhat smaller differences that are driven by the demand elasticity. And if I take eta, so it's 0.3, if I take eta up to 2, you see a supply elasticity, it goes from 0.3 up to 1. So basically the supply elasticity is what's driving things largely. And then next thing would be the Armington elasticity, and the third is the demand elasticity. So I'm just showing you that you can generate results. And here the key thing is that if I look at my pivot data, I have epsilon, I have eta, I have sigma, then I have what region I'm reporting, what item I'm reporting, and what the value is. So the main challenge is I want to run the model for a bunch of different values, and I want to save them and get them all into a pivot chart, right? That's the logic of how to do that. And I don't know a simple way to do this. I know how I do it. I'm not sure whether maybe somebody listening in is smarter than I am about how to do this stuff. But I'll show you. I write a code called SSA Gen. I was going to try to avoid showing you how to do this, but it's the only way to know. So I say, okay, well, the sequence of scenarios I'm going to run is 1 through 1,000. And I'm going to basically generate a mapping that goes from the scenario number to what the values are, epsilon, eta, and sigma in each of those things. So I declare a set, which is a tuple that maps the scenario number onto these guys. And for that purpose, I keep track, the scenario number goes from 1 to the number of scenarios. and I use this fancy stuff. I declare epsilon, eta, and sigma sets, and I can get their cardinality, and I can generate an integer that represents the product of the three. That's how many different scenarios I have to run. So I declare that as a mapping. And then in my SSA run, then I go, if there's a GDX directory, I get rid of it. Otherwise, I create one from scratch. And once I've got the GDX directory, then I generate a file that will run my model for each one of those scenarios. And if I look at SSA, why does this thing keep turning on? I wish I could just tell it to go away and stay away. So if I look at my GMS file here, it's SSA run. This generates a run for each one of these guys. I guess when I hit up, man, this is really annoying. So I generate a run for each one of the combinations. And I've given them numbers 1 through 27. 3 times 3 times 3 is 27. I have the runs. So now I know which number, and in the process of doing this, I keep track of which run number goes to what combination. So I create this mapping file. And once I've got the mapping file, then I basically rerun the same program to merge. And so the operation merge, and if it says merge, it jumps down here. It grabs the results from the GDX with the scenario indices, and then I move it into the report and here I have the label. So here I'm using the mapping that goes from the numeric numbers of the sets onto what the elements are. That moves that stuff across, and then I stick the resulting PCT value. So PCT without the underscores are the percentage changes from the merge data. And then I basically, anyway, so this is an example of how this goes out. I'll send this to Martha so you can see. It's a sort of a working example. But once I've got that, then it goes through and runs. So and that all goes out like there. One thing I was going to say that's a little bit when you keep numeric values. So that says GAMS SSA run. That goes through all these 27 simulations. It's a wider range of parameter values, but that gives you a sense about how this works. So once you get all those guys solved, which takes a little time, it does the merge, and then it calls the thing back and it dumps the values into the Excel file. And if I then go back to my Excel file, SSA results. So this has got the results in it. And the one thing that's annoying is that when you work with pivot tables, it's helpful if the keys are numeric. You like to keep them numeric because then the pivot table sorts them accordingly. So at this stage, what I always do is I click 1 and then click all those columns, and then I go convert to a number. And that way I have all the keys are numeric, and that way the pivot table will work. And once I've rerun stuff, then I can say right click, refresh data. That reloads everything. Okay, so this is just a template that explains how to do a systematic sensitivity across a wide range in one shot. I apologize for being a little bit cryptic, but it's on the other hand, I think back when you and Weigel were doing systematic sensitivity analysis, this was something that took. Didn't you run something on the VAX 11 that ran for like 3 weeks? I remember that they had. There was some, yeah. So these guys were really into this at one time. All I can say is it's a little bit stupid. It's not like I'm going to generate a whole pile of numbers, but at the same time, it is a way to communicate your degree of uncertainty. So there's a lot to be said for getting a bunch of results. Here I have just systematic, so I'm enumerating all possible cases. You could also just do a Monte Carlo run where you do a loop and generate lots of simulations, but this is it's organized. And you can see that there are effects. There's going to be winners and losers, and gives you a sense about what the ranges are. Okay, so we'll save this guy, and then I'll distribute this. This goes with the oil sanctions model there. I guess now we're at the last session in the afternoon, and I thought the thing I showed you a worked example where I'd taken the model and carefully constructed a set of simulations to try to get this tariff quota liberalization of 232 taxes, tariffs, and I showed how to set up a spreadsheet. I thought it might be fun to do one more example with the model where we have, and one thing I thought might be kind of a fun, provocative thing that occurred to me a couple of days ago when I saw the Brits were going to try to walk back their treatment of Northern Ireland. I thought it might be fun to do a simulation where we have an EU-UK trade war and see what's the distributional effects on households and states of such an outcome, right? So this is just to be provocative and show, but it's more about, okay, we want to do the model. Let's go find, and the basic sort of working strategy I have is, okay, I have a scenario I want to do. I go out, look at my library about what model's closest to what I'm trying to do. I grab that model and I work from there. Here, if I look at, so I'm back in the WiNDC framework. If I look at my GTAP WiNDC underscore MG, here's my model. And I'm going to say, I'm going to call this UK-EU trade war, or war.jms. So that gives me those guys. And then if I look at what's the data set that I want to use, oh, I have to, I wish I could get this guy to just go away.
Oh, I can do that. It's fine.
So where do I get, so here it's going to be run.gms. So here I say GTAP 32, what I want. So I'm going to say this guy, if not set DS, GTAP 32 CPS 2014. So now I'm working with the full 32 sector model. If I look at my data files, data sets, GTAP WiNDC, there's GTAP underscore 32 underscore CPS. That's got all those guys. And then if I look at what the sets are, or where the mappings were, I'm going to say, let's read the file and let's just do option R:001 display R. So now that's a quick, I'll just do a quick thing. I'm going to say AMS UK-EU war. And so those are the regions we have in this segregation. Oh, rats! I don't. Which one was the one that? I think it's 32 sectors. But what's the?
Oh, right.
001 says no decimals. It's a set, so it doesn't matter. 0 means give me list format with one entry per row. So that's it's sort of cryptic, but then if I go to 001 format for displaying a set, then when I display the set, it displays the set and the description and the text description of everyone, so I can see exactly what these were. So I'm afraid I'm not going to be able to do I thought the UK was separated, but it's put in with Western Europe, right? So that's not so good. Yeah, exactly. So let's just do one where we say, let's do a free trade agreement with Europe. Okay, so that's going to be here, and it's going to say, so if I look at this model, quad colon M, there's where the trade, and let's just look at the tariffs. So it's going to be parameter tariff, and it's going to be I, and it's going to be bilateral tariffs. So tariff of I comma USA is equal to 100 times RTMS of I, comma, Europe and the USA. So that shows the US tariffs. And they're going to say Europe. This will be US, USA into Europe. And then we'll also look at RTXS. So this will be RTMS. Again, these are the GTAP names for the bilateral tariff. So that's RTMS, and then we'll look at RTXS as well. This is just my own approach. Is I could go back and look. I'd like to look at the actual data I'm going to run with to see what we have. RTXS. My guess is these guys are already very small. Tariff, give me 1 decimal point, 1 label on the rows and 2 labels on the columns, display tariff. So that's actually tariffs and export subsidies. So again, I'm going to put this in at the top, say exit. Oops, I forgot to put this guy. This is going to... So now if I look and see what we've got here. So those are the tariffs we have. That's the import tariff in the US. There's the export tax. So we have, this is what the database tells us we have. It's going to be very small. The effects are small, but the tariff rates in Europe are somewhat higher or US. So this looks, they're not zero, and the trade flows are pretty big. So let's see what happens if we set both these guys equal to 0, right? So this is a simple thing. I go into the model, say, okay, so that I've given a value of that. I'm going to say RTMS of I, comma, USA into Europe equal to 0, RTXS of I, comma, USA into Europe equal 0. So, and I'm going to say abort such that round of GTAP WiNDC dot obj val indus 2 . This is where I was saying you have to be careful when you do really small simulations. You have to be very careful about this calculation, and you might want to do an exact calculation at the benchmark, because the benchmark is off by like a small amount, and then you do a tariff simulation that has a very small impact. The changes may not be, it may be the noise that you get from the imprecision of the benchmark may actually dwarf what the effects are of the policy. That guy goes like this, but here we'll say dot iterlim equal to say 1000. And then let's first verify that we can solve the model. So there's the benchmark equilibrium. 10 to the minus 4th, it's pretty tight. And there's the simulation where we let the thing, and it's going to have to take a few iterations. It's got, let's see, what size is this? 14,000 rows and columns. So it's not an ultra small model. It's reasonably good size. It inherits dimensionality because you have all the states and all the households, and so you end up carrying more stuff on. But up till now, I've had very good luck with the data set. Usually when data sets misbehave, when you have trouble with solving, it usually is because you haven't done the data construction carefully. So it's very important to have this process of getting rid of values which are very, very tiny. You have to do this cleanup of getting rid of stuff that's not relevant. So that gives us there's 2 steps. 10 to the minus 3rd, that's pretty good. So you can see there that that's giving us very good performance. It's getting, basically the thing is giving us a really precise handshake. So all I did is I grabbed the model, did a replication of the benchmark, I did a couple displays to see what the values were in the benchmark with the exit. And then I put in a simulation at the bottom to do the basic simulation. I don't try to get the simulation precisely. I just try to get something running and I verify I can solve it. The one thing I didn't do that I usually do, save the solution point there. Because then when I work on the reporting, if the solution point is sitting there, then I can load it and I don't have to wait for the thing to solve. It took like 30 or 40 seconds to solve, and I can get that down to like 5 seconds if I have to store the thing. But let's first look, before we go forward, let's just look at what we get here. This is, let's rename UK EU dot star. It's going to be Europe FTA dot GMS. So to be more precise about what we're doing. So European Free Trade Agreement. And let's first do search for C. And now we can see here, this shows what the effects are. And we can look at, for example, Iowa comes up first for some reason. I guess that label gets loaded first. So you can see that there's the effects across Iowa, about 0.5% of GDP. Not so different. Florida, relatively much smaller, like 0.1% of GDP. Not a big difference across households in those states. 1%. Tennessee gets about 0.2%, relatively small. And just looking now to see across other states which ones. So some of those guys are pretty big. So that's Nebraska is getting driven pretty. It's 4% or no 0.4%. So it's not zero, but it's bigger than 0.2%. And so you get a sense about the effects across households, and that basically gets the thing lined up. I haven't done any reporting. I'm just looking at the way Jim worked yesterday, just looking at the listing file. You can see what the values are, get a feeling of whether this is something that looks like it's working. If I look at Europe, so Europe, rest, it has a very small impact. So the impact on Europe in the data set shows a very small effect. Europe, I don't have, and we can do the same thing with the UK. But just to show the saving, when you're doing this sort of stuff, it's helpful to be able to save the point file. So I'll just show you how you do that. You say .save point equals 1, and then you say if. Oh, wait a minute. I changed the name of the file, so I want to say if exist p.gx execute load point. So this is the standard syntax I would use for this is I say, okay, I'm going to save it into a file that's a point file _p. It's model name _p. And then I look to see whether there's a Europe FTA _p.gx. If one exists, then go get the solution file, then solve the model. And so if it, at that point is the solution, it will solve really quickly. And then I move the file, the point file that gets generated here, I move that over. And that way I'm able to restart the process really quickly. I look at this now, I can say Europe FTA. And once I have this moving, then I can go on to my reporting. And the advantage is that then it's going to take a little time to get this solved. But once I get this running, then I can basically turn around and change the reporting. It doesn't really change anything in terms of the speed. I'm running a little bit low on energy here, but I guess the basic idea here is to get a sense about the heterogeneity across states of the impact. And it might be interesting then to see which sectors and which states are affected. So why don't we just go down and while that's running, I'm going to say parameter report. This is a summary report. Report of S. So this is going to be, let's say Y %. S. I. And then it's going to report of C% state household. Again, I have a tuple that controls how this works. So say if it's going to, I'm only going to report the ones that are in the model, and that's controlled by this guy. All right. And finally, just to avoid having there be small numbers and knowing the report, I was going to round these guys to 1 decimal point. That way we don't have to mess around with stuff that's small, doesn't generate it. So that all looks like that. And if I look at my model now, I should be able to have this, and now I should be able to say, run it one more time. Whoops. Always make a bug the first time I do it. This has got to be USA. So now there's the handshake on the benchmark, one iteration, and it loads the file. It should be right at the point. It's a bit of a dense model, and so the first solve takes time because it needs to construct what the non-zero structure is of the matrix, and so it takes a little while because of all the households. 250. Come on, baby. So there it's you can see the solution. It still took time because I had to construct the Jacobian, but the first residual is 10 to the minus 7, so it's right at the solution. Now let's look at what we get coming back. So there's consumption. So here we see effect across households. Boy, they're not always progressive or regressive. There's differences across different states. It's pretty flat. South Dakota, well, it's interesting. South Dakota has the biggest gain. I'm not sure what the sector is, so now we'll see what that shows what these guys are, and this shows what the effects are on output. That's percentage change, and that shows by sector. I don't know what alt is. That looks a little bit strange. That's going up 264. There's something weird going on. I don't know what that one is. The other ones look on the whole. So anyway, this gives us a sense about what's happening across different states and some heterogeneity. So GAMS does not, what I did notice here that I said here, I said round. So if it's less than 1.1, less than 1/10%, just won't show up. Give me that way because otherwise GAMS has this annoying thing where it converts it to a floating point, to a scientific notation number, and I'd prefer to not see, okay, so it's a small number. Well, I mean, it's like, that's just, all this is quick and dirty, just like, can we see the effects? There's some of these guys that look a little bit strange, like I'm not sure where the big numbers, where these numbers for alt is coming from. It's probably something that's really a small number. So some of the stuff is a little bit strange, but this just shows you the basic idea here is that you get a model, you replicate the benchmark, begin by specifying a scenario which is roughly in the ballpark of what you're interested in looking at, get the solution, save the point file so you can rerun it and start the process of running reporting. I haven't really even scratched the surface here, understanding what the factors are. There's ways you can decompose the effect to understand which factor markets affect which guy's income. So there's a variety of additional things we'd have to do at this point. Yeah. Should make a version with the UK. It'd be more provocative if we have something that's a trade war. So I will, maybe we'll see if we can do that. The thing is that the data set that we can generate, we can distribute for free has like 10 or 11 sectors. So we can't, we have to be a little bit careful, but maybe we'll see if we can get the UK in there so we can make that as part of our distribution. I did that at the beginning. So that's, I think that guy is all, the SSA gen is the file. So I'll send this to you. So that's the generator file. You just run that and then just verify this guy works. You run SSA gen and GAMS SSA run. And then yeah, oh yeah, I could go back to look at Sam's numbers. I think that might take me longer. We only have 10 minutes or have it? Okay, okay. I'm open to suggestions, but let me look and see what Sam's code looks like. Is there anyone else that has a question or a specific okay. So if we go to the, Sam sent me something, but I didn't have a chance to look at it yet. It just came in. So let's just say I'll stop sharing here. I'm going to go look. So if I'm just looking at what this, I think the thing I don't understand is exactly how the calibration works here, because we have very elastic oil supply and high elasticities of these guys. I'm not sure exactly what's going on with theta, because we have numbers that go, were these the actual trade flows, or are these, I'm not sure what the units are here. Let's not see. This directional flow. So it looks to me like this should actually be, if I have this right, it looks to me like she's got flows. That's 110, 113, 232. So I'm not sure I understand how the demand, what it's meant by theta. I mean, if we look at the model we had that I put together, I was reading in what the trade values were and computing both supply and demand from X0. So that's a little bit, I'm not sure I understand. So I'll have to communicate with Sam about this to understand what the numbers were. There are other questions here. Let's see. Okay. SSHN. Okay. So this is going to be and then if I look at what's the XLS file I have, SSA results. And if I can go over here, so that's got the model file with the SSA links in it. So this is the SS. And the that's got the code and the pivot table. You may want to double check that it run, because I'm not sure if I have a backslash. Anyway, there's this question about the, yeah, so. Sam, did I misunderstand? What's your theta? Are those the benchmark shares, or are those actually, are they the supply? I'm not sure I understand your input data file. Okay. So there's, yeah. Okay, great. So I'm just about done. Yeah, so I think yeah, so the game plan tomorrow, we'll talk about tomorrow morning. We'll go through the representative agent dynamic model and the procedure for solving an OLG model. I have a operational code I'll go through for Canada, and I'll show we'll go through what steps are for doing this same thing, and we'll talk a little bit about OLG modeling. I'm a little bit, I don't really have much of a feeling of who's here or what. So tomorrow, if you're interested in this stuff, come with some questions. I'm happy to look at stuff, whatever we have going forward. We'll start at 8:30, and the game plan is to get done sometime tomorrow afternoon. Probably, I don't know if we're scheduled to, what are we scheduled to go till tomorrow?
Scheduled as normal.
Okay.
1 to 2:15 and 2:30 to 4. But if you want to change it,
yeah,
we can do that.
I think the material I have, we should be able to get done by 2 is my guess. So tomorrow we'll probably not extend a long time. We'll do one session after lunch, but please come tomorrow with, if you have questions about things, I'll be happy to handle that. Well, that's the reason I just, yeah, it's a challenge.